Hey everyone, this is guys and welcome back to another video, and today we're going to be looking at flip-flops and counter circuits. So we've got a bunch of designs here of varying complexity and style. So let's get down to this. So first up, what are flip-flops and why do you need them? So when you flick a lever, it switches on the lamp, and if you flick it again, it switches off. But the problem is you can't really do that with a button or a pulse, which is one of the most common outputs in a redstone signal. So basically, in case you want something to remain switched on after it receives a pulse, you want to use a flip-flop. So what exactly are we going to do? So a concept that's going to be used here is if you've got a sticky piston and power it using an observer or with a one-tick pulse, it actually leaves the block behind. So as you can see, if I update the observer, the redstone block gets left behind. And if I update it again, it retracts, unpowering the redstone lamp. So the question is, how do we use this in a common redstone circuit? Now, in case you have a pulse being updated by an observer, you can see that it updates the observer, but then it re-updates the observer, pulling the redstone block back. So this is not a viable solution. What we can do is one of these things. This is a falling edge circuit. We've got a normal piston and a gravity block there. The redstone signals are left just pass through for exactly one tick, which causes the piston to spit out the redstone block in the back. You can just see the redstone repeater powering on temporarily, and yeah, it switches on the lamp, and once you power it again, it switches it off. Yeah. Okay, the next design we're going to be looking at is an only observer design, which we've got over here. We've got a sticky piston attached to an observer, and the observer extends, powering this sticky piston back here on a one tick. Once it retracts, it doesn't power it again. You can see the redstone block gets left behind. And once again, it just keeps the redstone block apart. Now, in case you wanted this to provide a pulse, you can actually change the circuit up slightly. Over here, as you can see, in the end, instead of the redstone block, we've got an observer pointing out this way. So once you flick it, you get a pulse, but the second time that you flick it, you don't get a pulse coming out of it. So this way, every 2 times you get an output. Every 2 times that you press the button, you get an output. Over here, every alternate time, you get a continuous output. So it really depends on what the circuit is to use it. So you can just chain all of these together continuously using multiple observers attached to pistons, like we do over here. If I flick this, you can see the lamp turns off. Flick it again, it remains turned off. Flick it again, it switches on, but if you flick it again, it doesn't turn off. So this stays on for 2 inputs and turns off for 2 inputs. But in case you wanted it to work every 4th time, you're going to have to tweak the circuit around a bit. And yeah, that's what we're going to do in just a bit. Okay, so in case you wanted it to, just not remain switched on between the inputs, what you can do is you can replace the redstone block with an observer. So we power it once, power it twice, power it thrice, and the 4th time you will get a pulse from the observer back there. And yeah, this is pretty satisfying. Every 4th time you will get a pulse. Now, in case you wanted a continuous signal every 4th time, you basically do the same thing, except you've got an extra set of pistons in the back and this observer here. It's the same observer layout except for these 2 extra ones. So you can see that powers. It has now switched off the redstone lamp. So you can see the piston observer setup up front is actually pushing the redstone block across until the end, where the redstone block is pushed back to switch on the signal. This is a pretty simple design. It's basically a double flip-flop type thing, which I'll explain in a bit. But yeah, this works perfectly. Every 4 times you get an output. You can obviously tile this as many times as you want to give it for every 8 outputs or 16 outputs. So what the circuit that I'm using to control this is pretty simple. It's something like this, where you've got normal pistons on either end. Parting the same piston twice doesn't reset the clock. If you part it from the other end, it turns it off. But you can't repart it to turn it on again from the same end. You do have to change it. Alright, so now we're going to look into some of the slightly more complex flip-flops / counters. We've got a bunch of designs over here based on piston-free tapes. And basically, the previous designs will only work for powers of 2, and this is meant to work for other ones. Over here we've got an observer which quickly passed the piston, and we've got some smart zero-tick pistons on these ends to make sure that the blocks get cycled around quickly, and the blocks just keep cycling around in a cycle in this shape. And what you can do is that every so often, based on a different type of block, you can take a quick output. Unfortunately, in this case, we can't really take an output out of completely solid blocks, so we're gonna have to tweak the design slightly. So to solve that, we are using some transparent blocks such as glass, and we've changed the parting mechanism as well. So as you can see, we've got transparent blocks which don't allow the signal to pass through. The observer drops down and passes the redstone line throughout, where we've got 2 tick repeaters going all the way through. As you can see, it cycles all the blocks around. Let's flick this a few times until the iron block comes through. As you can see, there is nothing going through that right now, so the lamp switched off. Okay, that's 1, 2, 3, so you can see, and yeah, the iron block is in path of the repeater and the lamp has turned on. And yeah, that's how you can do it. Now, an alternative is to use composters. Now, the reason you use composters is because they do have some container value when they move. You can also use cauldrons, but I mean, composters are cheaper. So you can actually take a compactor output from a composter if you actually fill it up with some stuff. Now, this can be basically, you can have multiple solid blocks. So say I have a solid block every 2 blocks. That means every 3rd time I flick the button, we'll get an output. This one is currently not the perfect size. You do have to experiment a bit. And yeah, now the maximum size you can have with this is 12 on either end. So that's 48. So every 48 inputs you can get 1. Now, obviously, to make this slightly faster, it would require to use solid blocks. And here we're going to be using the redstone block being able to power things. Now, we're using a target block here to redirect the redstone line, because otherwise it wouldn't work. We're once again using smart pistons, zero-tick pistons, so that it gets done fast enough. That redstone line would get redirected whenever the redstone block came in the way, which is why we're using target blocks. If that wasn't clear. Okay, let's actually just place a redstone block here so that it gets done faster. Okay, 1, 2, you can see it doesn't really break the piston-free tape, and it completes the circuit and lights up the lamp here. Okay, the next design is a bit more weird. This is using an interesting concept with target blocks redirecting redstone lines. Once again, using only solid blocks. We've got a sticky piston here which temporarily powers the redstone lamp. So let's actually send this off a few times. Okay, the target block is allowed to pass through. The target blocks are obviously solid, which is a really useful thing here, and as you can see, the lamp is switched on and the shape of the redstone line has changed, and yeah, it's back to a cross now. So yeah, this can, once again, you can just have multiple target blocks based on how many times you want it to power. Okay, we go finally into the final set. Now, as I mentioned, the previous one can only have a maximum of 48 ticks, but over here we're using a dropper counter, which has got 9 times 64, 576 possible items. So yeah, what we've got here is we've got a dropper feeding into a hopper, which basically turns all the way around. goes into that hopper, goes all the way across, goes into that hopper, and that hopper is currently locked. So no items are fed right back into the dropper. We've got a comparator taking the output from that, and we've got a sticky piston here, which will, after it empties out, will unlock the torch. And we've also got a lamp there for the output. So let's actually flick this 9 times. How many times is that? Okay, 3 times. So we've got 6 in there, 7, 8, and wait for it, 9. So you can see the lamp turns on and the redstone block has moved, and it's moved back. So yeah, that during the time that the redstone block was in the original position, it allowed all the items to basically drain out. Okay, the next thing we're going to be looking at is a bit of a weird one. Once again, this is using kelp and bamboo. Now, kelp and bamboo can both be bone meal. One major problem is bamboo and kelp can also grow on their own using random ticks, which is a bit of a problem here, but you can actually block it. The reason bamboo doesn't work is because there's a tiny chance that it can grow 2 blocks at a time. But once it grows to the desired height, you've got an observer there which sends out the output and also breaks the bamboo at the bottom. Kelp is a tiny bit more well behaved, because you can actually just block up the kelp growth using a lever there. And more importantly, kelp only grows by 1 block every time you bone meal it. So you do have to part it, say 5 times in this case, before it grows to its full length. And yeah, it switches on and signal is passed down and it's broken, and it's good enough to reset. These things are really useful to use in fast contraptions rather than slow ones like the others. Okay, the final one is using warped warts and warped nether wart blocks, because when they are placed in a composter, there's a 100% chance of them converting. So you need 7 inputs to switch on the composter. So anyways guys, thanks for watching. This means Kaisif, and I'm out. So ciao for now, and I'll see you later.